Welcome to my presentation. In this presentation, let us show that if we have vector A and if we were to multiply or if we were to cross product that with vector 0, the result is going to be equal to 0. The result is going to be equal to a 0 vector. The same thing if we have a 0 vector and then if we were to cross product that with vector A, the result is going to be equal to 0. In here, this is example 6. In this here, this is example number 6. So let us try that. To prove that, we will let vector A have the following components. If A has 3i minus j plus 2k, and if the 0 vector has 0i plus 0j plus 0k components in them, then we want to show that vector A cross 0 vector is going to be equal to 0. So let's do that. Vector A cross vector 0. We can use the determinants to show this. So we can write I, j, k. For vector A, the coefficients of I are 3, the coefficient of j is -1, the coefficient of k is 2, and the coefficient of I for the 0 vector is 0, the coefficient of j is 0, the coefficient of k is 0. So therefore, if we were to expand this along the first row, and if we were to use the sign convention, positive, negative, positive, positive, negative, positive, and if we were to expand this is how it's going to look like. I, the minor of that, -1, 2, 0, 0, minus j, the minor of that, which is 3, 2, 0, 0, and then plus k, the minor of that, which is 3, -1, 0, and 0. So if we were to expand this, I times 1 times 0 is 0, minus 0 times 2 is 0, minus j times 3 times 0 is 0, minus 0 times 2 is 0, plus k times 3 times 0 is 0, minus 0 times -1 is 0. Therefore, we have 0i minus 0j or plus 0j plus 0k. So this is a 0 vector. So vector A times a 0 vector, the resulting vector is a 0 vector. So we have proved that a vector A multiplied by a 0 vector is going to be equal to a 0 vector. This is how we can use the properties of vectors, cross product or vectors, and then prove that we can perform vector operations in 3 dimensions. In my next presentation, we shall look at some more examples related to vectors using determinants and then solving problems in vectors in 3 dimensions.